Pumps are used to transfer and distribute liquids in various industries. Pumps convert mechanical energy into hydraulic energy. Electrical energy is typically used to operate various types of pumps. Pumps have two main purposes: transfer of liquid from one place to another, circulate liquid around a system. The main components of the pumping system are pump casing and impellers, prime movers, electric motors, diesel engines or air system, piping used to carry the fluid, valves used to control the flow in the system, fittings, controls, and instrumentation, end-use equipment, which has different requirements for pressure and flow. There exists a wide variety of pumps that are designed for various specific applications. However, most of them can be broadly classified into two categories as mentioned below: positive displacement, dynamic pressure pumps. There are two types of positive displacement pumps. First type is reciprocating pumps like piston pump, diaphragm pump. The second type is rotary pumps like gear pump, lobe pump, screw pump, vane pump, plunger pump. The types of dynamic pressure pumps are centrifugal pumps, propeller pump, turbine pump. The term positive displacement pump is quite descriptive because such pumps are designed to displace a more or less fixed volume of fluid during each cycle of operation. The volumetric flow rate is determined by the displacement per cycle of the moving member times the cycle rate. The flow capacity is thus fixed by the design, size, and operating speed of the pump. The pressure, or head, that the pump develops depends upon the flow resistance of the system in which the pump is installed and is limited only by the size of the driving motor and the strength of the parts. Consequently, the discharge line from the pump should never be closed off without allowing for recycle around the pump, or damage to the pump could result. Reciprocating pumps. Pumping takes place by the motion of the piston or diaphragm in the cylinder. It is often used where a relatively small quantity of liquid is to be handled, and where the delivery pressure is quite large. Piston pump. A piston pump is a type of positive displacement pump where the high-pressure seal reciprocates with the piston. The pump has a piston cylinder arrangement. As the piston goes away after the delivery stroke, low pressure is created in the cylinder, which opens the suction valve. On forward stroke, the fluid filled inside the cylinder is compressed, which opens the delivery valve for the delivery of liquid. Diaphragm pump. A diaphragm pump uses a combination of the reciprocating action of a rubber, thermoplastic, or Teflon diaphragm and suitable non-return check valves to pump a fluid. Sometimes this type of pump is also called a membrane pump. In rotary pumps, relative movement between rotating elements and the stationary element of the pump causes the pumping action. The operation is different from reciprocating pumps, where valves and a piston are integral to the pump. They also differ from centrifugal pumps, where high velocity is turned into pressure. Rotary pumps are designed so that a continuous seal is maintained between inlet and outlet ports by the action and position of the pumping elements and close running clearances of the pump. Therefore, rotary pumps do not require valve arrangements similar to reciprocating pumps. Gear pumps. A gear pump uses the meshing of gears to pump fluid by displacement. They are one of the most common types of pumps for hydraulic fluid power applications. The rigid design of the gears and houses allow for very high pressures and the ability to pump highly viscous fluids. Lobe pump. Lobe pumps are similar to external gear pumps in operation, in that fluid flows around the interior of the casing. As the lobes come out of mesh, they create expanding volume on the inlet side of the pump. Liquid flows into the cavity and is trapped by the lobes as they rotate. Liquid travels around the interior of the casing in the pockets between the lobes and the casing. Finally, the meshing of the lobes forces liquid through the outlet port under pressure. Screw pump. These pumps are rotary, positive displacement pumps that can have one or more screws to transfer high or low viscosity fluids along an axis. Although progressive cavity pumps can be referred to as a single screw pumps, typically screw pumps have two or more intermeshing screws rotating axially clockwise or counterclockwise. Each screw thread is matched to carry a specific volume of fluid. Screw pumps provide a specific volume with each cycle and can be dependable in metering applications. Vane pump. A rotary vane pump is a positive displacement pump that consists of vanes mounted to a rotor that rotates inside of a cavity. In some cases, these vanes can be variable length and/or tensioned to maintain contact with the walls as the pump rotates. Rotary plunger pump. The pumping action takes place by rotating the rotor and reciprocating the plunger. In a rotary plunger rotary pump, the axes of the plungers are perpendicular to the rotational axis of the rotor, or at an angle of not less than 45 degrees to the axis. The rotor is located eccentrically with respect to the axis of the case. Suction and forced delivery of the liquid occur with the reciprocating motion of the plungers as a result of centrifugal forces and spring action. Rotary pumps of this type may have as many as 72 plungers arranged in multiple rows. In a dynamic pressure pump, during pumping action, tangential force is imparted, which accelerates the fluid normally by rotation of the impeller. Some systems that contain a dynamic pump may require positive displacement pump for priming. They are normally used for moderate to high discharge rate. The pressure differential range for this type of pumps is in a range of low to moderate. They are popularly used in a system where low viscosity fluids are used. Centrifugal pumps. They use a rotating impeller to increase the pressure of a fluid. Centrifugal pumps are commonly used to move liquids through a piping system. The fluid enters the pump impeller along or near to the rotating axis and is accelerated by the impeller, flowing radially outward into a diffuser or volute chamber casing, from where it exits into the downstream piping system. Centrifugal pumps are used for large discharge through smaller heads. A propeller pump is a high-flow, low-lift impeller-type device featuring a linear flow path. The propeller pump may be installed in a vertical, horizontal, or angled orientation, and typically has its motor situated above the water level with the impeller below water. These pumps function by drawing water up an outer casing and out of a discharge outlet via a propeller-bladed impeller head. Turbine pumps are centrifugal pumps that use pressure and flow in combination with a rotary mechanism to transfer fluid. They typically employ blade geometry, which causes fluid circulation around the vanes to add pressure from inlet to outlet. Turbine pumps operate using kinetic energy to move fluid utilizing an impeller. The centrifugal force drives the liquid to the housing wall in close proximity to the vanes of the impeller or propeller. The cyclical movement of the impeller produces pressure in the pumping bowl. The shape of turbine pumps also contributes to suction and discharge rates.